In this video, I will introduce the concept of the cylindrical shell method. So back to the disk and the washers method, I already explained how they came up with that idea, right? For the disk method, I explained why do you have to use the top curve minus the bottom curve for the radius, why do you have to use the right curve minus the left curve, and then in the washers method, I explained why you have to use the outer radius minus the inner radius. So everything has a concept, same thing in the shell method. So in the shell method, we are going to build from scratch, and then I will show you how to do this step by step until you reach to the formula for the shell method. All right, so for the shell method, we will have to use these two key pictures. So the first picture, I have a cylinder. And then what we have to look at is we want to find the volume of the yellow region. So do you see that there is a cylinder, three-dimensional? There, actually, you can think about this. There are two cylinders, one big, one small. The small one is in red, the big one is in yellow, and then we have a space, a gap or a shell between the red cylinder and the yellow cylinder, and we are trying to find the volume of those yellow space. All right, so let's take a look at the top. So if you move your eyes to the middle of the video, so I am looking at the top of the cylinder. So at the top, I have two circles, one red, one yellow. Now, look at the center. What is the inner radius? So the inner radius will be R2, right? Actually, I forgot to write the R2 over here. So this is supposed to be R2. So R2 is the inner radius from the center of the red circle to the edge of the red circle. So that is called the inner radius. And then what about outer radius? Outer radius is R1. So that will be from the center to the edge of the yellow circle. So inner radius and outer radius. What about R3? R3, this is called average radius, is from the center of the cylinder to the middle of the yellow space or the yellow region. So how do we get that? We take R1 plus R2 and then divided by 2. So basically we are taking the average of the inner radius and outer radius. And then H is the height of the cylinder, and then the delta X is the thickness of the shell. Now, geometry question. How do you find the volume of those yellow space? How? So first, this is the concept. So first, what we are going to do is I am going to find the volume of the entire cylinder. Okay, just the entire one, the big one. And then I find the volume of the smaller cylinder, which means, simply speaking, first you find the volume of the yellow cylinder, and then you find the volume of the red cylinder. So the yellow is big, the red is small, and then in order to find the shell between the red and the yellow, you will using the big volume subtract the small volume. So basically you have one large yellow cylinder, and then you scoop out the center, which is the red cylinder in the middle, and then the leftover is the shell. So that's how you do it. Let's take a look at the formula. So to find the cylinder, we have to use pi times radius. So what is pi r squared? Pi r squared is only the base. And then once you multiply the h, so pi r squared is two-dimensional, is the space. Once you multiply the h, so you have a bunch of circle, you use a bunch of piece of paper and then you cut the circles out. So when you multiply the h, it looks like you are stacking the circles up. So you have one circle on your table, and then you put one on top of that, and then you put one on top of those two, and then eventually you will get a 3D object. So that's how mathematician came up with this idea. So we have volume equals to pi r squared times h. Of course, we have one for the outer and one for the inner, the red and the yellow. And then to find the volume of the shell, which is the three-dimensional yellow region, we will be using the outer minus the inner cylinder. So how we do it? We use pi r1 square. So the r1, the subscript 1, stands for the outer radius. The subscript r2, r subscript 2, represent the radius of the inner cylinder. And then the square, we have to square the radius. So pi r1 square h minus pi r2 square h. And then what we did in the second line is, so in the second line, right here, I factor out the pi, and then I factor out the h. So now I have pi f on the front and h on the back, and then in between them I have r1 square minus r2 square. And then the next thing is you have to factor the r1 square minus r2 square. So do you still remember this? A square minus b square is equals to a plus b times a minus b. And then we put this factor right here, r1 minus r2 times r1 plus r2. So if you FOIL them, open them up, multiply them, you will get r1 square minus r2 square. And then we have to do some magic, so I have to multiply a 2. So look at the 2. Answer a question for me. Did I change the formula? The answer is no, because I multiply 2 first, and then I immediately divide the whole thing by 2. Basically, you take a number, you multiply by 2, and then immediately you divide the product by 2. So you didn't change the equation, you only change the outlook of the formula. So I have multiply by 2 and then immediately divided by 2. But when I divided by 2, I put the r1 plus r2 on top divided by 2. Why do I have to do this? Because that is how I get the average radius. And then the h stays here. So r1 plus r2 goes here. And then these two and these two, they just cancel each other, but I need them to be there. And then the r1 minus r2 goes to the back. So now let's put all the pieces together. So we have a 2 pi, that is 2 pi, r1 plus r2 divided by 2. I just call that r. R stands for average radius. You don't need to call that r3 anymore. Just call that 1r, that stands for average radius. H is h. R2 minus r1 is the thickness of the shell. So let's go back to the picture really quick. R2, oh, actually that is r1 minus r2, right? I just make a mistake right there. No wonder they don't look right. So this is r2 minus, r1 minus r2. I was writing that too fast. So r1 minus r2. So I brought that straight from here, right? Straight from here. r1 minus r2. r1 minus r2. That is called delta r. Why do we do this? R1 is the longer radius, R2 is the shorter radius. When you subtract them, that is the distance between the yellow circle and the red circle. So that's why we call that a delta R. You don't need to call that delta X and delta R, same thing. And then we write our formula. So the volume is equals to 2 pi R. So the first piece, 2 pi R, and then times the height, times delta R. So what do they call? The 2 pi R is the circumference. The circumference of the shell. And then the height is the h. And then the thickness is the delta R. So for the shell method, if the revolution axis is horizontal, then you will be using a dy integral. If the revolution axis is vertical, then you will be using a dx integral. So that is the concept. And when you set up an integral to find the volume using shell method, you have to find the circumference, the height, and the thickness. So this is only a formula. Regarding the detail of the shell method, I have to break this down into multiple videos, so which means you will have to watch the next video. And that is also the end of this one. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me. Please share this video for me. Do you prefer to watch this video or you prefer to read the book? I believe most people prefer to watch a video, right? So share the video for me. Subscribe to my channel if you haven't done so. Appreciate your help and support. See you all in the next one. Signing out for now.